Hello, everyone. In this presentation, I would like to talk to you about the sensor and sensor types. And this is a part of the IoT lectures. I'll be doing a series of IoT lectures, and you got to start with the sensor and sensor type. Okay. So in this presentation, the thing in IoT, when you think about the Internet of Thing, and when I first heard it, it wasn't really clear what is the IoT stands for because they call the things, right? It's not really clear. So for the things, the Internet of Things, you got to start with the sensors. It's something like as a human, we have a different sensors, right? You have a hand, you have a feeling, you have eyes, you can smell, you can touch. But when we talk about the robots and the AIs and when they process the environmental information and when they process the decision making, they have to make a decision based upon the informations, right? So sensor can provide information about environment, smell, like light, humidity, and temperature. All those information is taken into account when the machines or the AI or robots make a decision. So the sensing part, it has to start with the sensors. So in this lecture, I'll be talking to you about the sensors and actuator and smart object and the sensor networks as well. So when you talk about the sensors, there are different types of sensors at the higher level. There are active and passive. Active requires energy. It will generate some form of energy to receive the information. Okay. So passive, it doesn't really generate energy. It receives some informations from the objects. So like you said on the right, active remote sensing is the satellite is sending out the information, and the Earth sends back information. In this case, is using the light. This is more of active. This is the passive. Light, reflect on the certain device. With that, you'll continue to send the information up there. And the passive is that you're receiving the information. Okay. So also when you look at the RFID side is more on the passive side, and scanner, it has to be more on the active side to be able to detect RFID. You don't want to have batteries located there because you have to change the battery, or sooner or later you'll be gone, right? There's also the invasive and not invasive. Invasive is you have to touch something to measure, like if you want to consider the water flowing on a pipe, so you have to actually have a sensor in the pipe so it can measure the water flowing, right? That's more of an invasive. Not invasive is you putting the sensor on top of the pipe. You're not actually implementing in the pipe. So since it's on the top of the pipe, so you will measure the water flow and some form of indication. It could be from the vibration or something like that. So it has to be work with some form of a machine learning, right? So there's contact and not contact is the contact is touching the. There's absolute and relative. Absolute means the reference point is zero. So when you say absolute temperature, it's a 33 Celsius or 22 Celsius, you're measuring from absolute zero. From that, there's some form of reference point. But when you talk about the relative sensors, there is no reference point. What is the current difference? Like an atmosphere temperature and your current temperature at a certain device. So it just gives a difference. So those are the two differences. And there's a different areas of application. I cannot mention all the application. There's agriculture from the I'm sure in your work environment, universities, and I see IoT, including like cameras, they're everywhere. So it's not going to be decreased, right? So those types of sensors and measures like a thermal, electronic, electrochemical, optic, electric, fluid mechanic, photoelastics, all those informations being uh, used, and the sensor will pick it up. You'll convert that into more of a, sometimes it's in the analog form. You convert that into more of a digital form and send it to the cloud or whatever it needs to take it to make a, decision. So those are the, those things. That there are a lot of other things measured by sensors, like infrared, or you can measure light, a lot of different things, and there's a lot of different sensor types as well. So like a position, it measures the position of the objects. And what do you call that? Even your phone, you can measure the position. Where the mobile phone is, located. You can tell that where the mobile phone is tilted, front or left. So position is, it's very fairly easy to detect. Okay, and you can detect whether his phone is dropping and at what acceleration, what velocity. Okay. So occupancy motion sensor detects presence of the people and animal. Sometimes you can use it in the surveillance area where the sensor detects any of the movement objects, and the velocity and accelerations indicate how fast is the moving object along the straight line. I mean, usually that's a detection of like a policeman's detecting the car moving pretty fast. Force, how physical force is being applied, how much push is being pressure as well flow, and there are a lot of things that you can measure. Okay, and also you can measure the acoustic sound, sound level, not just the sound quality. You will convert it into digital form, and humidity, light, radiation, temperature, and there's also different type of chemical, carbon dioxide. Even smoke detector, you can detect chemical as well. There's a biosensor detects a biological element, organism, tissue, cells, and enzymes, and things like that. As you can see, sensor can detect a lot of different objects, or it can detect speed, it can detect the atmosphere, a lot of different things. So um, so those informations are converted to digital form, and they feed into the, for example, in the cloud. Those information used to make a decision. So everything starts with the sensors. So one of the sensors I would like to share with you is a biodegradable sensor. Is developed by North Dakota State University for smart farming. Is typically this is the sensor that measures what do you call it, the moisture level. I remember using this type of sensor at the desert or in a Saudi Arabia somewhere. What happened is that you drop this sensor into the farm, into the lands, and into the area that you want to detect. It basically measures the ground moisture level. Okay, so after a while, what happened is that those things sometimes the battery operated, and it no longer function, right? You will relay those data to multi-hop to the collector. The collector sends to the cloud. So sometimes it's no longer functioning. Is that means that someone's gonna come and pick up those and throw it away? No. And those sensor, what it becomes is that it becomes a biodegradable. It will just you degrade into the soil, becomes a soil. So you don't have to detect. You don't have to clean up those kind of things. Okay. So those types of sensors exist. When you look at the sensors and smart cameras, now I have an iPhone, and a lot of you have Android, probably a Samsung Galaxy. It does have a lot of sensors already comes with it, right? So it has a camera, fundamentally, it does have, a touch screen. It has a thermometer, it has a GPS. Also it can detect your location. It can do fingerprint sensor to log in, microphone, moisture sensor. All of those sensors are kind of built in. This is the current trend. So believe it or not, there are a lot of visibility. Okay, so growth prediction of the sensors, the number of sensors is going to be, I can't even count how many those. Quintillion, I don't know, but it will continue to increase. Continue to increase. I don't see any declining of it. I want you to know that sensors and actuators are something you make it used to work and moving. So, from the real environment, what happens, this is a feedback loop. In the real environment, sensors collect the information, right? Anybody doing AI or data science? One of the most important thing is data, right? So sensors can provide those data. So you will collect, sense, and measure, send it to the digital represent electronic signals. It can process the information. What does it mean? It can perform machine learning, or it can perform using that information to make an adjustment to the real physical environment. Because sensors giving one information, you can use that information to calibrate whatever you're doing in the physical environment. Typically, how these things works in the real environment, like this. Okay, a lot of feedback to make an adjustment so that whatever is built, make sure it's a function smoothly as possible. Okay, so sensors, at the higher level, it's more like I said before, it taste, smell, hearing, eyes, all of those being, for the human, for the human, those are the sensing stuff. For the machine, we're using sensors, right? Machines for the brain, and we're using more of a CPU for it, and the actuator is it gives instruction to move something, right? So it has a foot and hands, and it has an actuator. Okay, so actuator is it can be classified based upon types of motions. It's a linear or rotary, one or two, three axles. And the power is actually classified in the power output, for example, high power, low power, how strong you are, right? How strong your arm. So whenever you use robots to providing information, so like a robot's hand, for example, right? It has a sensors on the fingertip. Whenever it touches the cup, okay, touches the cup, it can feel what that is. It will try to lift a little bit, if it's not happening. So it's kind of trying to measure the weight. And with the fingertips, it can kind of feel whether it's a soft object or it's a hard object. Based upon that, with the weight, the machine will process how much power does it require to lift this object. Okay, so you get power output. It needs to be able to determine that. So also there's a binary continuous actuator class based on number of stable output. Their area of application in the industry vertical right now is a big trend is IIoT. There's AI, IoT, artificial intelligence, IoT, industrial IoT is being used. There are so many different applications. So okay. So actually classified into energy type. There's a mechanical, electrical actuator, resistor, bipolar transistor, mechanical, electromagnetic. There's hydraulic, right? Hydraulic actuator. There's a smart material actuator, basically a memory alloy or ion exchanger fluid, biometallic strips. and things like that. And there's a micro, nano, very small electrostatic motor, microbulb. So a lot of cases, those kind of things, you know, sometime they use in the human body for certain functions. Okay, you know that artificial hearts, you know, in the valve, it's not actually micro nano actuator, but it's you know, it's actually being placed in the heart, replaces the heart, so it will act as a pump. Okay. So there's a micro electromechanical system. It's basically a function of a sensor and the actuator. So inkjet printer uses a micro pump, MEMS, and smartphone uses MEMS technology as well. This is one of the picture. Okay. So when you talk about we talked about sensors, right? And we're gonna move on from sensors to smart objects. So sensor is probably the smallest area. So next level is when you collect the number of sensors or one sensors, you can create smart objects. So we're gonna look at what a smart object consists of. We're talking about here a processing unit. It's a smart objects, right? So you have to process the information. So it needs to have a processing unit, and also probably needs to have some memory as well. And also sensors, actuators, sensors to collect, you know, information. So you gotta, if you want the object to be smart, you gotta have some form of information. So sensor can, you know, provide that. Okay. Sometimes you need an actuator to move, depends on you know, sensors output and communication device. You have to relay that information to another device, and you need to have a power source, whether it's a solar power or operated by the battery or some sort of. Okay. So when you look at it, the characteristics of smart sensor, typically what smart sensor have are this. Has a CPU, memory, power source, like I indicated, communication device, actuator, and sensor. So it's current trend of smart objects, you know, basically. So what are these? You could have just a light bulb with connected to the Wi-Fi, making a, you know, some form of decision whether there's a human coming to the room. It will detect that, and it will turn on the light. Just simple function as that. You need to have all of these components. Okay. So it's been used in many different places now. It's everywhere. Okay, even camera, you know, things like that. But the current trend is, you know, size is decreasing. So it becomes smaller and smaller. It's very easy to hide. It doesn't take a lot of the power. Because of that, you know, power consumption is decreasing. But it's getting a lot of information. So processing power is increasing. So you need to have more power. So is the power going to come from the landline, land power, or the battery, or, you know, it could be from light, converting light to electric source. Excuse me. Communication capability is improving. So no big, you know, those capabilities keep improving. Now Zigbee, and we have low power Bluetooth. Wireless speed is, you know, increasing. Okay. So communication being standardized. This is the current trend. Okay. So advantages of, you know, there's a great deployment flexibility. It's a scale is a bigger advantage, and you can create a lot of this. Okay, it creates a large number of nodes because it's cheap. It's a lower implementation cost and easier long-term maintenance, and also effortless introduction to new sensor and actuator node, and it's also very equipped to handle dynamic rapid topology. So potentially, one of the weak point is that it's not your computer, it's just like a mobile device. There's IoT being less secure, right? So it doesn't really have a processing power to, even bandwidth to handle the cryptography, or, that's too heavy. Excuse me. Okay, sorry. So, potential less power, that could create a lot of the problem. Okay. So, design constraint for wireless and smart objects. There are a lot of, things to consider. You do want the moderate CPU power, and you want the low memory as well. You don't want to have rely on a lot of the memory. Of course, the memory comes in pretty cheap these days, but it cannot have abundance of memory. I mean, communication is another issue. Not reliably connect, stable, and it's not able to transmit a lot of the power. Okay. So here are the limitations. Limitations of processing power is small, limited memory, and the loss consumption, and the limited transmission speed. Because it's small, right? And it also limited power. If it's operated by the battery or former lights or some sort of, those are the limitations I would like to just share. Okay. Okay, I just want to stop at this, and you can watch let me see, you can watch the next video, okay, which is Internet things. Okay, thank you.